Hi, this is Miss Park, and this video is about the relationships of sides in a right angle triangle. So I'm going to show you a right angle triangle that I made. Okay, and right angled means that it has an angle that measures 90 degrees. So this angle here measures 90 degrees. We show it with a little square like that. Okay, and I'm going to show you a little relationship between the sides. If I call this little short side little a, and call this second longest side B, then this longest side here, we'll call it C. Okay, now we know it's the longest side because in a triangle, the length of the side is going to be related to how big the angle is that's across from it. So see how the 90 degrees has to be the biggest angle because they must all add up to 180 degrees. And so this one and this one together will add up to 90. So that's going to be the biggest angle. That means the triangle opens the widest at that point. And so this side across from it is going to be the longest side. And this side has a name. The longest side is called the hypotenuse. Hypotenuse. And then the two shorter sides are called legs. Leg and leg. Okay, so there is a famous relationship called the Pythagorean Theorem. Okay, so let me write it over here. The Pythagorean Theorem that says these sides are actually related. If I take the square of side A, so little a squared, and I add to it the square of side B, I'm going to get the square of side C. And so a squared plus b squared equals c squared, where c is always the hypotenuse, the longest side. So these two, the order doesn't matter, but this one has to be the longest side. Now, the Pythagorean theorem is named after a Greek philosopher mathematician named Pythagoras, but actually it was known for hundreds of years prior to Pythagoras. The Babylonians used it for construction. The Indians knew of it, and the Chinese knew of it. So it was actually, it was around long before Pythagoras made it famous. Okay, but it is named after Pythagoras. So let's show you why this is true. So if I take my little triangle here, and I'll just show you like a little visual. If I take this little a squared, it really means I'm finding an area of a square that is length a by a. So here I've made a square that is length a by a, and I'm going to put it right there. Okay, and then another square of length b by b, so that the area of this one is a squared, a times a, and the area of this one is b squared, b times b. Well, it turns out that those two areas added together will equal the area of this big square, which is a c by c square. So a squared plus b squared equals c squared. And there are lots and lots of proofs of this available. You can search it up online. So just a little bit of an example now of how to use the Pythagorean theorem. So it is used when we have a right angle triangle and we don't know one of the lengths. So let's say, for example, I have a right angle triangle. Okay, and this is going to be 6 centimeters, and this is 8 centimeters. Then what's this one? Okay, so what we'll do is we'll say that we'll call this one A, and we'll call this one little b, and we'll call this one C. And we'll write the Pythagorean theorem. So always write formulas first before you use them. And then in the next step, you can put in the side lengths that we have. So we have little a and little b. It's the long side that we're looking for. So 6 squared plus 8 squared is c squared. You can use your calculator or use your mental math. 6 squared is 36. 8 squared is 64. That's c squared. So this is 100 is c squared. So some number squared is 100. Some number times itself is 100. So what is that number? Well, we get that by doing the opposite of square, which is the square root. So we'll take the square root of both sides. The square root of c squared is just c. And the square root of 100 is going to be 10. Okay, so therefore c equals 10. So that's how we found it. All right, another example is we use the Pythagorean theorem to find one of the legs, so one of the shorter sides. So let's say I know that this one's 20. and this one's 11, and I don't know this one. Okay, and diagram is not drawn to scale, but that should be okay. So label it A, B, and C. Remember, C is always the longest side. A squared plus B squared equals C squared. 11 squared plus, I don't know this, so I'll keep it as the variable B squared, equals 20 squared. 11 squared is 121 plus B squared equals 20 squared is 400. And so B squared now, we want to isolate the B squared. So we'll subtract 121 from both sides. And now B squared is equal to, you can use your calculator or use your head, 279. Okay, and then B is equal to the square root of 279. Okay, now, if you know the square root of 279, that's great. If it's a whole number, that's great. But if it turns out to be not a whole number, so in this case it's not, if you used your calculator, you'll get some kind of decimal. We just leave the answer like this. We do not use a decimal answer unless it's a word problem. And the word problem, it makes sense to use decimals, okay? But if we're just going to use numbers, we're going to leave the answer like this. And usually there's going to be some kind of units. So this might be centimeters. And so your final answer will be in centimeters using units. Okay, some applications of Pythagorean theorem could be, let's say you're building a house and you know that the house is 30 meters wide. Okay, and you have a roof that looks like this. And we know that the height of the roof is, I don't know, let's say it's 6 meters. I'm not sure. I don't know. That's probably a really big roof. Okay, then how long is this? How long is this slanted part? So what we'll do is we'll take this picture and we'll make a right angled triangle out of it. And we'll see that if these two are the same, that makes an isosceles triangle. So that means that this height that goes down here is going to split the base in half. So this will be 15 meters. So I'll have 15 here and 15 here. The height is 6 meters. And they might ask, okay, what's the length here? So we'll use the Pythagorean theorem to find the length here. Okay, or maybe there's a ladder and it's leaning against the wall. So here's a ladder and it's leaning against the wall and you want it to reach a window that is 3 meters high. And the ladder is, I don't know, 1.2 meters tall. How far away from the wall, from the base of the wall, does the foot of the ladder have to be? Okay, so we know every time there's a house, a wall, that's a right angle triangle. Okay, and so we'll use the Pythagorean theorem. This squared minus this squared is going to give us this squared. Okay, always be sure that you know which is the longest side. Okay, and practice. And thank you for watching.